Okay, so this is an example of the data access layer for the case of the activity. So we're gonna follow in the code the activity feature and see how it is implemented in all of these layers. So we start with the data access layer. So what happens is that we have objects in the in our system. So, and actually they need to be persistent, and to make them persistent, you are going to store them in a in a relational database, and this requires that we map them to the database. So you need to copy them from the database, from the relational database, transform them into objects, we change them and put them back into the database. So the data access layer is responsible to do this, basically for mapping the objects from memory to disk and back to memory, and also converting, because actually an object is not the same that a table. And so I'm going to show you how this is done in the code. Okay, so we're going to look first to these. So I'm gonna actually I need to talk with a class that is here in the domain layer, right? So the class is there, here, but actually I'm not going to concern about the business logic of the class, but I'm going to concern about its mapping to persistence, okay? And then to see what happens there. So I have this class, okay? And I have an activity repository that provides some actions to read and write into the database. So I will start here. So actually, so when you use GPA, you provide this interface that you can extend, saying that in your case you have an activity. Okay? And then you can do SQL or SQL-like queries. It depends on how do you write it. I will show you. And that convert, for instance, in this case, I have a query. And this is pretty much what you have seen when you learn about relational databases. But actually, I'm using the name of the object. So I'm using the name activity. So I'm selecting objects of type activity where it's institution, so activity as a reference to institution. The institution ID is equal to some value that I pass here. So it basically gives me all the activities of an institution given the institution ID. And what's nice is that it returns objects. So actually it accesses tables and returns objects. This query is not a native query. I can write here native queries like this, but then I need to put it here. In this case, I'm directly referring to a database name. I will show you this name, okay, in the database. This is actually a class, okay? Actually, there's also a table associated with this, and if I use instead of this name the table, then I should put here that is native, and I can use plain SQL code. Now, let's look inside these activity. So, in order that it's mapped into the database, I need to have this entity here, okay? And optionally, I can say that's the name of the table. If I say nothing, Basic is gonna generate a table with this name, okay? But this is automatic generation. Then I have my business logic there, but I need to put always this attribute. So, because every object needs to have a unique identification in the database. So each tuple has a unique identification, okay? It's relevant for queries, okay, as you have seen here. So I use this ID here, okay, not in this case the ID of the institution for my query, okay? So, and that's, so I define there are several generation policies for the IDs, but I get this. Another thing that I can do is I'm gonna define relations between different entities. So in this case, all these attributes are automatically mapped to columns. It's pretty easy. I don't need to say anything, so it's smart enough to do the transformation. But in this case, for instance, when I'm referring, for instance, in the case of the institution, an activity is associated with an institution. But an institution actually is implemented in a different table. So I say that on this side, I say that is the relation many to one. So many activities are related to one institution. If I move to the institution code, so look, institution is again a persistent entity and as an ID, I will find here that institution has a list of activities. Okay. So what does it mean? It means that is a one-to-many relation. And then I say that is mapped by institution. What is this institution? So it's actually the attribute on the activity class that I'm going to use as a foreign key. So basically in the generation, this table is going to have a foreign key to institution that uses this. Okay? And that's actually what I'm saying here. Okay? Actually, this one, when the code runs, so the cron executes this, it generates the database automatically, and I can show you can just go here and you can query the database. For instance, you can see all the tables. For instance, you can go to the activity table and see its structure. Look, what do I have here? Oh, sorry. It's just the activity. Okay. And as you see, so you have this column, the ID. Look, something that we put there. Then, for instance, you will find the name column. The name column is there. Okay. But more interesting is the reference to the activities. So let me see, activity, the reference to the institution. And in the reference to institution, I have this institution ID there. Okay. And you'll see that actually institution ID is a foreign key, is defined as a foreign key. So it's nice because this generates automatically the database, but you can always check what is generated. Okay, here. So, but there it supports more relations. So it supports one-to-one, many-to-many, and one-to-many. So you have seen this example of one-to-many, okay? And there's here an example of many-to-many. So in this case is list, okay? That actually, or that team, there's a many-to-many relationship between activities and teams. And in this case, I'm gonna say which table I'm using. So because how can I implement a many-to-many relationship? In this, there are different ways to do it. In this case, we are saying I want it to have in its own table. So which is activity teams. So if I come back here and say the activity teams, we'll see that basically is a table that defines the many-to-many relationship because it has two foreign keys, one for activities and another for teams. Okay, so it's a table that implements this many-to-many relationship. And returning back to the beginning of the presentation, here I'm deleting all the relations between activities and teams. That's what I'm doing there, right? Because basically that's it implements that relations. Okay. And that's it. Okay. Thank you.